everybody, it's Mrs. Pound, and we are working on Chapter 7.3 on the Sun, the Earth, and the Moon. Today's topic is going to be on eclipses from Section 733. So our objectives today are going to be to label the parts of the solar and a lunar eclipse and distinguish among different types of eclipses. So an eclipse, what is an eclipse? It's the casting of one celestial body's shadow on the surface of another celestial body. And eclipses are actually pretty cool. In ancient writings, they are mentioned, especially during certain wars and things. So if we're not certain when a battle occurred, we can actually use evidence from eclipses being mentioned to determine when that battle occurred, because we can actually, because the motions of the sun, the moon, and the earth follow a certain pattern, we can actually go back in time and figure out when the eclipses occurred, and we can figure out when future eclipses are going to occur. So that is some of God's predictability in the universe is a really cool thing. So the first type of eclipse we're going to talk about is a solar eclipse. This is an event that occurs when the moon passes directly between the sun and earth, causing the moon's shadow to block the sun's light from a portion of earth. And here, this is a total solar eclipse. You can see the corona of the sun in the background. This occurs during a new moon only, so it has to be the new moon phase. And it's not observed by everybody on the lit side of the earth because the moon's shadow covers a small portion of the earth. So not everybody's going to see this. There are two parts to the shadow. There's the umbra, which is the dark central portion of a shadow that completely blocks the sun's light in this picture. And there's a penumbra. It's an area of partially blocked light surrounding the completed shadow. That's like that first picture where you just saw a little bit of the sun being blocked. That would be if you are in the penumbra. And then there are what are called annular eclipses. This is a solar eclipse during which the outer ring of the sun is visible around the moon. You're only going to get a total solar eclipse during perihelion, when the earth is closest to the sun. Otherwise, you may see one of these annular eclipses because, like I said, the conditions really have to be just right to see a solar eclipse. So on your worksheets that I provided earlier, take those out and label your diagram for the solar eclipse. Here we can see what I was talking about. The moon has to be in the new moon phase in order to block out the sun. So the sunlight's coming in on the moon. The moon is between the sun and the earth for a solar eclipse. The umbra is produced, so in this very small portion on earth here where that white part is, that's where you're going to see a total solar eclipse. The penumbra extends out, and that's where you'll see a partial solar eclipse. And only on the lit side of the earth will you see this. And actually, the shadows here are a lot larger than they really are on earth. You're usually only going to see a very small swath of earth, like a path like this perhaps, where you're actually going to see either a total or partial solar eclipse. So this diagram really does not show that. Not everybody is going to see this solar eclipse because it's going to be a small portion of the earth because the moon's shadow is really quite small on the earth. Now, if you've ever seen a solar eclipse off to the side of the solar eclipse area, write to me what you thought about that. Either say, yes, I have seen one, and write what it was like, or write no to show that you're listening. Okay, the other type of eclipse that we can see is a lunar eclipse, and this is an event that occurs when Earth passes directly between the sun and the moon, causing Earth's shadow to block the sun's light from the moon. And you can see the progression of a solar eclipse in the background, and the moon doesn't really completely disappear. It appears to be kind of reddish brown. This only occurs during a full moon. So the moon has to be opposite of the Earth, farthest away from the sun, in order to see a lunar eclipse. And it can be observed by everybody on the dark side of the Earth because Earth's shadow can completely cover the moon. So take out your diagram of the lunar eclipse and label your diagram. And what you see here is that for a lunar eclipse, we have to have a full moon. It's the Earth that's casting a shadow on the moon. And so here we see everybody on the dark side is going to see a total lunar eclipse because it's in the umbra and the penumbra spreads out. This is not always the case. There are partial eclipses where it will not eclipse the whole thing, but everybody is going to see this because the Earth's shadow is much larger in comparison to the moon's shadow from the other diagram if you take a look at those. So you're more likely to see a total lunar eclipse. Now, actually, there tend to be more solar eclipses than lunar eclipses. But the reason that we see more people are likely to have seen a lunar eclipse is because everybody's going to see it on the Earth. Okay, everybody has a chance as long as it's not cloudy and everything. Where for a solar eclipse, not everybody has that chance. So you're probably more likely to have seen a lunar eclipse. And if you've seen a lunar eclipse, next to lunar eclipse, tell me, yes, I've seen one, and tell me what you thought of it. Or no, I have not seen one. Okay. Now, eclipses do not occur every month because the sun, earth, and the moon must be in perfect alignment. The moon must be in the Earth's orbital plane or it won't happen. And it is not always in its orbital plane. So the conditions have to be just perfect. And solar eclipses are shorter than lunar eclipses because the size of the Earth's shadow on the moon is much larger than the size of the moon's shadow on the Earth. So they happen much faster. It's really, the progression takes quite a long time, but the time that the eclipse is happening in totality is just a matter of minutes that it lasts. So make sure that you have labeled the parts of the solar and lunar eclipse, and our objective was to distinguish among different types of eclipses. So don't forget your 5 questions, and I will be back with one more video for this chapter.